Hello, everybody, and thanks for joining us for our afternoon sessions. Really, excuse me, pleased to have with us Srikanth and Anchula. He's a senior chemist with the Viswa group, and he's intrigued all about oil analysis. And today he's going to be talking to us about ferrography analysis of wear particles of cylinder lube oil systems in commercial marine ships. Okay, thank you so much for joining us, and please take it away.
Good afternoon, everyone. Today, I am going to make presenting like the ferrography analysis of wear particles in the cylinder drain engines on board commercial marine ships. So it is quite different compared to industrial analysis like steel, cement, and power plants and all. So marine industries are very quite different and all, but analysis test methods and all same as compared to here and all, but some taking recommendations, corrective actions and all. So very quite different compared to industrial and all. So I'm going to explain today this only about the ferrography analysis in SGD cylinder drain analysis. So going through and so first I introduce you all background of what is the marine industry and what is the how many ships we have like in all are the floating in the sea. So many different type of ships we can see in the ships and all. Some are container ships, some are crude oil, some are bulk carriers and all. So I can show you all the what is the background of marine industries in the ships and how it looks like and all. So here you can go. There's a dry cargo ships like that. There is a several ships is there. Some general cargo ships like that. We can up to 20% of all fleet it's occupy and all. And specialized cargo ships also we can see, and container ships and all. And this is a bulk carriers, dry bulk carriers like dry means coal, iron ore, sometimes other materials like that. It's we can carry on these ships and this and all. And this is a liquid cargo ships. We can see cargo containers and liquid bulk tankers, liquefied gas carriers and all. So chemical carriers and also it's a very critical equipments on the ship. Sometimes we cannot have some sparks and coming and also the entire ships will collapse and all, getting the fire and all. So we need to monitoring the equipment health and reliability is very closely monitoring and all. So we need to maintaining the reliability equipments in the very good at this. And if you can see inside the ship, so you can see inside that there is a two-stroke engine is also you can use, and four-stroke engines also you can use, some smaller ships and all. And four-stroke engines also use some auxiliary engines for electricity purpose in the ships and all. So and two-stroke engine is only for propulsion purpose for moving forward and backward like that. So here is the two-stroke engines. We can go explain you, and there is a different types of cylinders units is there. So cylinder 1, cylinder 2 like that up to 12. In meanwhile now as of now 12 is the main biggest ships I seen. So that's Wärtsilä manufacture is made that 12 cylinder engine. So that is very big ships and also there. And also here you can see here, so this is the main engine and also this is a two-stroke engine. This is the shaft, propeller shaft. This is the stent tube and also it's a back of the ships and it's giving you moving forward and all. So like that and also. So what the main purpose of cylinder oils, or why we need to use cylinder oils, and what is the importance of cylinder oils? So why we need to use? So the main purpose I can show you that lubricant used in the piston and liner. So this is the piston and all. This is the two-stroke engine and all. This is the piston we can use here. So you can use from here the oil coming and all. This is the feed rate and all we can fix and all. It's a spray on the liners and all, so liners and rings and all. So you can so reduce the friction and introduce the wear protection and all. It can improve the wear protection and all. So minimize the risks of the sizeners and also so there is we can it's lubricant help to the reduce the gap between liner and piston ring. So it cannot allow the blow by combustion by products and all allowed in the system. So neutralize acids and oxygen byproducts according to engine requirements. So some whenever fuel is burned in the ship, that time engine, that time that there was some blow by products and all coming also very acidic and all. It's because of the sulfuric acid in the fuel and all. So it's burned and all some acids generate and all. So it can reduce this the things and all. So and keep piston rings and ring liner clean as important to the ensure free movement rings by managing preventive excessive deposits and build up. So it's a help to the clean the deposits and all in the cylinder oil. So selection of the cylinder B and related the fuel content and all. So here it is the graph showing. This is graph showing how to we select the which type of fuel we are going to use. That so with the so based on that we are going to use, we can select the how much base number we want for our oil and all. So here so you can see here down fuel sulfur content in percentage so 0.1 you can use bn 15 to 25 when UK. So bn 40 to bn 60 and so it's 1.5 so below 1.5 all are VLSFO and above 1.5 is the HSLFO. HSLFO, VLSFO is a very low sulfide and all, and HSLFO also high sulfuric acid and also sulfur and all. So it can choose the based on the fuel in sulfur content in that one. So what is the feed rate? The feed rate is the very most important thing in the any ship, any two-stroke engine and all in marine ship and all. So once you fix the feed rate and all, so it can help the where generate and all. So you can choose and also to able the engine wear and the steps must be completed with fuel sulfur content that is high enough to the extrusion cylinder feed rate and accumulated cylinder oil comparison and all. This means that your feed rate must be above the minimum 0.6. If you put in the 0.5 also, it's a way there is no lubrication between liner and rings, so it can some wear out problems and also if you put above 1.5 and all like that feed rate you can fix. Sometimes it's high deposits of the calcium and all, it been stuck in the piston rings and between liners and all. So sometimes it's going to very hard material between liner and rings, so it when sees the piston and some cases is there. So interpretation of oil analysis for cylinder oils with BN 40 or higher. So there is so here you can see this is the graph showing you so how to we how much iron wear we need to maintain in the cylinder drain analysis and all. So residual BN and how much we can choose and all. So here you see this is the safe area. So this safe area is the 25 to 50. So BN whatever it is, it's I am giving example here only BN 40. So you can downward trends up to 25 also allowable and up to 50 also allowable. So you can choose you can whenever you done the cylinder drain analysis, so your total base number results showing this and all. So use 25 to 50 is your oil is very safe and all. At the same time you can you can choose up to 200 ppm iron in the element analysis. So you can it's a safe safe area and all. So you can go to 500 ppm in iron wear. So it's a alert area and above 500 ppm in any unit like unit 1, unit 2 in the engine. So whatever it units, so it is a danger area in that. We can consider in the whenever we see the oil analysis report. So this interpretation is very much important for these two parameters, very important in any marine ship engine analysis that time. So you can choose wisely and all. So you add, if you don't have any your test package, you add your laboratory people, so you limits and all, they follow the limits, you can give to them limits and all, so it's easy to understand. So what is the criticality of your equipment, and so you can take the about corrective actions. Is a corrective actions means you can you want to increase the feed rate and you want to decrease the feed rate and all, so you can choose wisely this same thing, right? So optimization of the feed rate, so very important, the optimization feed rate and in ship engine. So you can to see, so interpretation of the feed rate as follows. So if the as the analysis show operation is the safe area, do one of the two instructions: continue the operation with the current feed rate and all, decrease the feed rate small step, for example 0.05 grams per kilowatts and hour per hour, like that. So you can reduce, and also so you can save your cylinder lubricant. If you oil going, your analysis showing is a very safe area limits and all, so you can small decrease of your feed rate and all, so you can save a lot of cylinder oil in your ship, like that. If the analysis show operation in the alert area, do one of the two instruction. In case increase or decrease the feed rate to get operation in the safe area. If necessary, change the BN of the cylinder and all. So if you increase decrease and feed rate and also, but it's not in the safe area, so you need to change the BN of the cylinder lubricant. So you are using like BN 40, so you can go to BN 50, like that. So it will helpful to you keep the your results in the normal stage. Keep feed rate and do regular inspection, piston rings in the liners condition, scavenge reports also. So once if you the results are any abnormal, like iron content where it's a 500 up by above 500 ppm and all, your BN is below 25, if you are using BN 40, so you can go and check the cylinder scavenge drain area and all. You can see the what is the lines in the liners and all, some wear outs in the rings and all, so you can see these things, the types and all. So if the analysis operation danger is here, so it will increase the decrease feed rate, the change BN of the cylinder operation. So if you sometimes it's increase, you put in the 1.5 above in the feed rate, and also there is a so much calcium deposits and all this and all in between cylinder piston rings and all, so that time, so this all are some hard material, it's go to the wear out the liners and all, so it's careful about we can see the feed rate correctly and maintaining and all, so that wear outs is showing and all above 500 ppm iron and all, so it's a very important thing we need to see the whenever we see the oil analysis report. So importance of the optimization. So why it's important optimization of the feed rate. So feed rate optimization is very important. So unoptimized lubricants are less or more can lead to wear gradually or accelerated. It can increase or decrease the wear in the engine and the unit engine unit and all. So it's a very we need to maintain the optimization the feed rate and all. So lubricating surface are more than required is also wastage of oil and economic loss. So lubricating surfaces and are more required. So sometimes you put in the more feed rate in the system, so so more oil into the spray, and also cylinder oils are very costliest lubricants in the industry, like we are using high BN numbers and all, So it's very important to maintain the optimization of the feed rates and here, and better performance of the engine when lubrication is optimized. So we need to maintain the correct feed rate about what we can see, and equipment manufacturer suggested and all this feed rate maintain and all. So that time we can see our analysis reports are showing a very normal range, and also our piston rings and all liners and all going good and all. Why cylinder drain analysis required for the ships and all? So cylinder oil is expensive and it cannot be reused. So once you use the cylinder oil, once you spray in the links and all, so you cannot use again that cylinder oil. So it is because of the so much all deposits and all this blow by combustion by products and all mixing the cylinder oil. So it's come under all our downwards and all. So it's very contaminated oil, so you cannot filter and all, you cannot reuse, and also it's and also a saving of 0. Grams of feed rate, 0. Grams per hour, and the feed rate on the 6-cylinder engine can generate the 60,000 in a year. So we are need to maintain the feed rate very accurate feed rate and all. So if you increase the feed rate and all, sometimes about 0.5 increase and all, you can lose the so much money you can last. So over lubrication could mean money down the cylinder drain. So over lubrication affect that one. And cylinder analysis will not only help you cut cost by optimizing cylinder lubrication, but also provide important information. So it's not only cost cuttings, and also it's also showing you provide important information like so how your piston rings. Piston rings, how it looks like and all, how it's going and all, how your liners and all also. You need to take any corrective action, you need to change the rings and all, you need to change the liners and all. So it show you the whenever you've done the drain analysis and all. So it's helpful to you. Combustion condition inside the engines and all. So wear rate in the rubbing parts of the cylinder liner piston rings. Potential for major problems result serious blow past by rings and contamination of the lube oils. So this is we can see the what is the type of elements we can found some in the oil analysis report through ICP. So elemental analysis. So nickel and vanadium we found more above 50 ppm, and also it's a combustion byproducts and all, we can say like that. So we can iron copper increase, and also iron is the iron and copper increase in our report. So you can understand there is a problem with the liners and rings between, so some wear outs is going on. So contamination and also water, the sodium, zinc, phosphorus, and also it's increase, and also there is a mixing with system oil. Sometimes it's a stuffing box failure and all between system oil and cylinder oil. So there is a between stuffing box failure and also your cylinder oil mixing with these things, and also water, and also coming from cooler pipes, and also some cooler pipes break in your these things and all, zinc and also phosphorus, and also you can see in the coolants and all. So addicants of the lubricants and calcium and TBN. So there is a increase in the calcium and the decrease of the TBN. Also you can see that there is a deposits between rings and piston between so many deposits and stick and all. After sometimes it's going to very hard material and all. So here you can see this is the piston and all, this is the yellow metal is the rings, piston rings and all. So once in the face of the ring, and also this is the wear line out, some scratch damage is found on the top of the rings and all. So this is the liners, and also you can see how your condition and all these things and all. So from broken ring into turbo change and so. So this is some scuffing results, oil film breakdown. Sometimes you do not maintain the feed rate and correctly, and also there is a wear outs between liners, and also this is rings and all, some wear outs and all you can see. So here these things and all. So we going to our main topic like that of oil analysis and all, ferrography, analytical ferrography. So you can see this. So this is the main parameters we are going to do in our cylinder analysis. So here we add ferrography analysis particles for this cylinder oil and all. So how ferrography analysis of drain oil contribute to optimization. So identify the type of air and all. So we can Spotify and all. What is the type of air? It is a copper. It is a chromium. It is a aluminum. It is a iron and also we can understand what is the inside the metallurgy of the engine and also we can see the what equipment need to action and also we can understand that one and all. So starvation of the cold lubrication neutralization of the conventional corrosive air. So we can see there is any water mixing in that fuel, so that is going to lead the corrosion of the piston rings and liners and also we can understand that under lubricating films also we can understand that what is the type of wear and also lubrication is going good or not, and that's all spray units are correct working correctly or not. Also, we can understand here. And visual inspection, onboard engineers cannot understand the what happening there, and so ferrography is helpful to you. So it's good thing going. Whenever you done the ferrography, so you can understand what is the structure of structure of inside the liners and all. So when wherever when wear out and all, you can understand these things and all. Accumulation particles contribution and all, some particles and also abrasive airs are like third body absorption and all, that cutting wear and also you can see understand. So this is the ferrography analysis. How we going to do? Step one, we are doing the um, WPC and all. So where particle concentration and all. There is a DL plus DS density of large particles plus density of small particles and all. So we can accumulate and all. We given the WPC where particle concentration, especially in the ferrous wear and all. So step two, we need to make the slides and all, glass slides and also we need to put in the magnetic things and also we can found that things and also, and after that we need to see the what type of types and all type and the severity component, cause of wear and all in the machine wear and all. So we see the morphology, size, contrast, concentration, so we can understand what type of particles is generated. Like this is a looks like this is a normal rubbing wear, this is the copper and all. So medium alloy steel and all, so gear wear, bearing wear and cutting wear. So we can understand this type of particles we see in the microscopic view. So we can say which type of failure it's going on, and it's a contamination about its no lubricant and all, feed rate increase decrease and also we can see and all. So WPC concentration, it's a completely trend analysis. So here you can see this is some trend 2019 to 2020, how gradually increase the WPC concentration here, 13,000 and also the start abnormality here and all. Then it's uh, uh, gradually increase the abnormality of the marginal condition and also it's a critical condition. So sharp increase in things and all within 6 months. It's a gradually increase 3,000 to 10,000 ppm is increase, like WPC increase in 10,000. So it's a very going to things and all. So compares between same engine type and all, compare WPC and all. So here you can see cylinder one is going a very normal range and all, 176, 98 and all. It's a gradually up and downs is there, but it's not increase and all. So but it is once you see cylinder unit 6, so it's the same engine and all, so there is some feed rate issues and all. So sometimes that's why we once in 2018 it's increased that thing. And after that we set up here feed rates and all, and we clean the things and all, whatever it is a little decrease and all. So we need to maintain and all for maintain for better double PC and all. So this and all. So comprehensive wear compared to wear particles and also you can see also particle size and all, severe sliding and also example severe sliding, some low lubricant and all, the improper lubricant and all. So same unit 1 and also unit 6, we can take examples like that. So you can see the sizes of the severe sliding wear particles in the range and all microns, this and all. So this is a lot also good and all. This is it's a better condition. This is the condition can be improved and all. So ferrosphere particles, and also you can see some types of gradually increase and all, how particles increase and all, medium elastic and all. So how things in the inside and all. So severe sliding particles also you can see some suddenly increase the 6 months in with improper lubrication and all. It's saying we can found this type of particle severe sliding wear and all. So thank you. If you have any question, please forward.
All right, thanks so much for that. I have like a quick question. Is there any filtration on these cylinder drains?
Sorry, hello.
Is there any filtration? Are there any filters for each cylinder?
We have no filter. It's cylinder. It's a feed rate. We need to spray on the between cylinder liner and piston rings. So there is no filtration and all. So once it's coming from the tank and spray unit and all, in between one filter we need to maintain some normal filter, not for any microscope filter. In 20 micron filter we need to maintain that.
Okay, I'm just thinking about any particles captured there, but if there's no.
Yeah, but we once it's a fresh oil, you cannot found it's a fresh oil.
Right.
It is.
Yeah.
So, but after that, you put in the oil into the spray and the cylinder liner. So once whenever up and downs and all, so liner and rubbing and all, so there is some gap, some milli micron sizes of gap. So in grab that under inside the holes and the spray coming on the sprays coming on the piston, so it's up and down that rings and all, some giving the lubrication there. So once that lubrication, you need to maintain the how much milligram you need to spray on the within 1 hour like that. So you put on the in setup boxes there, that spray unit. So that is the most important, because the cylinder lubricants are very high costly lubricants in industry, more than synthetic oils and all, because we are using a high TBN and all, right? So we need to maintain the TBN range, like 100, sometimes 100 TBN also we need to use for high sulfur fuel fluids and all. So that time, so it's very costly. So if you a small amount you reduce and all, so you can save a lot of money in that one. But if you reduce small amount, that means sometimes there is no improper lubrication going in the liner and rings. So it automatic you wear out some the liners and all. Liners about like 120 to 30 crores of Indian rupees like that. So you can lose of that much money in the, you need to, in order to maintain the proper feed rate and all.
Got it. Okay, thanks for that, for clarifying that. And obviously you're matching the base number to the sulfur content of the fuel. So we have a question from Yo. Essentially, how will the use of low sulfur fuels affect the cylinder oil wear?
Yeah, it's whenever you're using very low sulfur fluid in the like 0.15 percentage of the sulfur in the fuel. So you need to, you don't need to maintain the more amount of BN and all. So there is no sulfur and all. So that means whenever your combustion blow by time, there is no additional byproducts and involving into the system. So there is no harmful gases and all not generating in that one. So that time you need to choose wisely on the what type of fuel you are going to use. It's a VLSFO or HSLFO, like a very low sulfur fluid or a high sulfur fluid like that. So this thing you keep in mind whenever you're selecting the cylinder lubricant.
Excellent. Okay. Well, thanks for that. I think that's our time for now. We really appreciate you joining us at LRVS APAC. Excellent presentation. I really like the ferrography images with the false colors on it.
Yeah.
Those are my favorite. But thank you for sharing, and we'll see you all at the next session.
Thank you. Thank you, Josh.